Very much, and thank you for being up this early in the morning. The title of my talk is Play CTF, because I believe it's a really great way to learn more about hacking and just improve your skills and what you know about the, yeah. So, let's see. Go. Okay. So my name is Fabian. I'm still a student at the Technical University of Berlin, still haven't finished my master's degree, and I also work as a freelancer doing penetration testing, most of the time things like code audit, and I'm doing a lot of application security, web app security. And that's kind of important to keep in mind because this is my bias onto the topic. This is where I'm from in the industry because, as you know, there are a wide variety of different kind of jobs and skill sets required. I also have a YouTube channel called LiveOverflow where I create hacking tutorials and also CTF write-ups, and so this talk is kind of a little bit related to what I do with the YouTube channel. It's not a big channel, but it's possible that you have maybe come across one of these videos. These were kind of like my viral videos. They were linked in some of the news sites that were reporting about the Nintendo Switch vulnerability and the Dirty Cow local root exploit. Just in case you have seen those, then you can connect the dots. So before we start, I just quickly want to recap what CTFs are, because I assume that most of you know what it is, but I just don't want to lose anybody already. So what is Capture the Flags? Capture the Flags are security competitions where you can solve challenges, hacking challenges, to get a good ranking. And here's an example challenge. The challenge creator would create a piece of software and it makes it intentionally insecure, puts a bug in there so that it can be exploited. In this case, the creator named this challenge Follow the Rabbit. It's a web challenge and assigned to it 200 points based on the difficulty. The challenge creator also places a secret file on the same server, and then you as a player, you have to access this website and you try to find this vulnerability, this bug. And when you are able to exploit this vulnerability and, for example, get a remote code execution, this allows you then to read out this secret file. And this file has then a secret code inside. That's what we call the flag. That's why it's Capture the Flag. And that serves as proof that you hacked the server. And then you can hand this into the challenge platform and you are awarded points accordingly. Okay, so to the structure of this talk. Because we only have 30 minutes, it will probably more look like this, that we talk mostly about a bit blah, 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 a little bit try make an argument why CTFs are great for you. And then in the end, I hope we can look at an example vulnerability that you can find in CTFs, possibly maybe more depending on how fast I'm talking. So let's take a step back and think about how different the jobs in our industry are. There are so many different kind of jobs a hacker could go into. So for example, there's classic red team pen testing where you maybe target corporations with thousands of employees, you send out phishing campaigns and you go on site, try to get access to their networks, and you scan services with Metasploit and Nessus and whatnot. You kind of have also this opposite where you go into bug bounties, where you target very single applications and you test them thoroughly. You could also do code audits. That's kind of what I'm doing a lot, so just reading a lot of code. There's also a possibility for just doing consultant in general, where you help companies design secure software before they even get implemented. And you can also be mathematical and do crypto reviews and build those complex protocols that are running on our secure messenger applications. You could also be somebody who just sits in front of Excel and does risk analysis and pushing around some numbers to see how much damage could be done or what the probabilities are. Or you are just a developer who has to write secure code, and that's good if you identify as a hacker and you are a developer. Hopefully you write, not as insecure code. And I believe, even though these jobs in our industry are so different, you would be better in all of them the more technical knowledge you have, the more detailed knowledge you have. For example, a red team pen tester who uses Metasploit might not have to ever write a buffer overflow themselves or understand it. There are just too many exploits in Metasploit to understand each one of them. But I believe that if you would know at least a few of them, or if you at least have an intuition for how binary exploitation works, and if you have seen a basic heap exploit, then you are better at it. You develop a better intuition for it. You probably make better decisions when to use certain exploits and when not to. And the same goes for somebody who just sits in front of Excel and does risk analysis. If you understand how complicated certain attacks are and how easy other attacks are, you will be able to look at the news about security and you will be able to identify the snake oil bullshit stuff, and you identify the stuff that is actually a real risk. So how do we even get there? How do we get even this technical knowledge to get one of these jobs? Generally, I mean, this is not meant to be, these are all just examples, doesn't mean to be complete. But maybe you have just been part of a community you find very early in your life, some online communities, or you've been part of hacker spaces and just, learned it while being part of it. Maybe also nowadays you just study it. Universities offer now classes on security, and some universities even offer degrees in this field. Or maybe you have, for example, transitioned from an entirely different job into the security field by investing into trainings and going to conferences and maybe also doing certifications. Or maybe you have also just been a developer who realizes, wait, I built these systems, I know how to break them too. This is kind of where I'm coming from. I was a web developer and I created websites, and then at some point I realized I always wanted to be a hacker, and then I realized, oh wait, with all the knowledge I acquired being a developer, I can also, abuse this knowledge. And I believe that generally the traditional way of learning and how we get into it, you will do a good job. You will know enough to raise the bar for the attacker in a meaningful way, and generally you are a good investment to have. But you all know that all of us don't know everything. We know that there are people that are way better than us, they have just a lot more skill, and if you would let them do the job, they may be better at it than you are. So we understand that there's a margin upwards, and depends on you personally, but I do want to, always take a step forward, always try to improve, and not be stuck at, a basic level. And with all this, there are still educational challenges in this field. For example, to not even fall back, you need to constantly evolve with the field. When I started out professionally as doing web pen testing 3 or 4 years ago, our clients had a lot of PHP applications, and nowadays they all just come with Node.js, JavaScript web apps to us. So if you have been really, really good at auditing PHP applications 4 years ago, then you are kind of just a noob again and a trainee at this point, even though maybe your role is a senior penetration tester because you did so well 4 years ago. Also, maybe you need to learn entirely new fields. What if a client comes to you and has a website that is interfacing with some kind of binary, maybe some audio processing or something like this? Are you able to audit this? Will you ignore that part, or what will you do? So that's generally, a broad field of knowledge is very beneficial. A lot of interesting vulnerabilities happen exactly where those different fields are intersecting with each other. And if you have knowledge on many different fields, you have a lot more interesting attack ideas and ways to hopefully exploit the stuff. And then we shouldn't also forget that hacking in its essence is something very creative. Hacking has always been something to play with technology, bend the systems, to the rules that were unintentionally implemented. And we shouldn't forget that, because especially in the business environment, everything has to be measurable, everything has to be able to assign a number to it, but then we lose this creativity. And with a lot of audits, for example, you kind of work through checklists. This is what happens in PHP applications, so you check exactly these things. But then there are these weird vulnerabilities that are unique to a certain application that you won't be able to check if you just follow those checklists. And I'm not saying that checklists are bad. Everybody has those checklists in their mind. But you should not be forced to just follow those checklists, and you should be allowed to be creative and explore entirely different areas of these applications. And I believe if you are aware of these things, and if you think about these and invest in these areas, then you are taking steps forwards and become better, and you hopefully get to this point where people are looking up to you and think, oh my gosh, you do a really good job. And I believe that CTFs are a way to solve all these challenges, at least for me. And it might not be for you, but I want to introduce it to you why I think it's a good thing, and hopefully it's for you as well. So the great thing about CTFs is that a lot of the vulnerabilities are just basic vulnerabilities. And those can then be used to just, see how well you are actually with those challenges. If you do web pen testing and try to solve a basic web challenge, then you can try to speedrun it and see how fast you are, just to see, I know my field. But you can also use those to get into entirely new areas. With my first CTF, I used it as an opportunity to go into binary exploitation. I was coming from web programming, and I did my first buffer overflow. It was something very basic, just jump into the stack to some shell code, and that took me probably days, I think. But I Googled the hell out of it, and in the end, I was able to solve it. And so I used this as an opportunity as an entry point in an entirely new field that seemed so far away and mystical to me. Then the other thing is that a lot of CTF vulnerability or challenges are kind of about esoteric stuff. And this is what is criticized often about CTFs, that they don't reflect the real life and what's realistic. But I kind of understand where this is coming from, but I also think those people that hold this belief have never actually audited clients' code. Because I have seen the weirdest kind of vulnerabilities in clients' code if you are looking for them. And that means being creative. And I agree with you that this particular CTF vulnerability will probably never be in an application that you audit ever. But that's not the point. The point is these vulnerabilities could theoretically exist, and the question is not whether it's common or happens a lot. The question is rather, would you be able to identify them if they were in this kind of code? And if you can't do this, then you maybe don't do the best job you could do. And then the third point that is also very important to me is that with CTFs, you will get a reality check. You will get a punch in the face, and you will fail. Because these challenges are really hard, especially the creative esoteric ones is where you really have to understand a certain framework or system or language to its smallest corner that is so uncommon. And this really shows how much knowledge you don't have or what skill you don't have. And this is good for two reasons. First of all, we are often very arrogant. And I include myself here definitely, I'm laughing at developers that write shitty code in the code I audit. That's just how it is. But it kind of shouldn't be. It's kind of a shitty thing to do. It's very arrogant. The other thing is that especially in my line of work where I write a report and audit code, I usually never get negative feedback of how good my job was. I sent out those tickets. They paid me because they didn't find it themselves, or generally they want to know how they are doing, so they trust me that I do a good job and find them. And there's no way to verify if I actually did a good job and found a good amount of vulnerabilities. And the good thing with CTFs is it's kind of like an exam where the solution is known. When you know that these challenges are intentionally insecure and there is something in there, and it's kind of also not a huge application, it's a small challenge that focuses on the small thing, and you will still fail to find this bug. And this is a good reflection on yourself. Okay, I'm maybe not that good yet, but I'm learning. So how do you get into CTFs? There's a website called ctftime.org. You can look on the upcoming events and generally look for the weighted events. Generally, the CTFs are running for a few days, like the one here at the conference, just like 2 or 3 days, maybe over a weekend. And I say look for the weighted events because this means they have a score attached because they have proven themselves in the past. Obviously, there are a lot of CTFs and a lot of also not that great ones, but if you look for those, then you know that you have a high quality CTF. They also might already be a bit too complicated. They are quite difficult, so maybe you have to look for some other CTFs, but generally it's a good advice if you check out for the first time and want to get your feet wet, look for those. Then I would suggest you just take out, for example, 3 hours of your Saturday afternoon and just pick out one challenge and dedicate the time to it. And don't play this challenge with an intention to solve it. Just, take a lot of notes, Google the hell out of it, and write down everything you can think of, every idea you have, even though you might not be able to implement it. If it's a binary, you say, this could be above overflow, but I have no clue what to do. Write this down. And then accept that you didn't solve it. And afterwards, and if you solve it, great, but most likely is be realistic that they are really hard and you might not solve them. And then you go afterwards on IRC, where the players are discussing their solutions. And this is a great learning opportunity to just read the chat, what people are sharing, their scripts and write-ups. And you can also look on CTF Time and GitHub and Twitter for those write-ups. And then what you can do is you sit down and compare those write-ups with your notes that you have taken. And this is then where you can learn, because you can analyze where did I fail, what did I miss, what did I not know about, was it just a carelessness that you ignored that you shouldn't have ignored, or was it an entirely thing that you have never heard about before that's even a thing? And this is really where the learning then happens. So that's good that I talked a bit faster, because now we have a bit more time to look into more technical stuff. It's a technical track today after all. So it's kind of like now some LiveOverflow mini episodes, just we go over some examples really quickly, and it's not meant to be that you understand them right away. I hope they are not all stuff you already know, and in general it's just more like that you know that these kind of things exist and that you are aware of those, and that when you test applications or when you play CTFs, that you have that in the back of your mind, and when you think that could it be, that's what it could be, then you can Google and learn and read up on it again. So the first example is about how Python compares objects or data. So here's an example. It's a website where there are 3 messages you are allowed to read. Only the last 3 messages. The message 1 and 2 are hidden already. You are not allowed to read them. I don't know what kind of application that is, but that's how it's implemented. So you can read the last 3 messages. And there's also a JSON API where you can send in the ID of the message that you want to read. So for example, here let's see how this works. You send in the ID 5 in the JSON format, and then you get back the message. And if you would try to access the ID 1, it's forbidden, obviously. So here's the piece of code that is implementing this. And there's a bug in there, and I won't let you take time to look at this because I don't want to waste time, I'm telling you. The title is already Python compares objects, so it has something to do with comparison. In line 8, the post ID that you sent in with the JSON request is coming in. And then after that is a comparison that checks if you're allowed to read the message or if it's forbidden. And it checks if you are a super user, but you are not, so bad luck. But then it checks if the post ID you entered is larger than the amount of messages available minus 3. So you are only allowed to read the last 3 messages. So we entered 5, and there were 5 messages. 5 minus 3 is 2. So 5 is larger than 2, you are allowed to read it. 1 is not larger than 2, so you are not allowed to read it. Now let's have a look how comparison works in Python. 5 is larger than 1, that's true. And 1 is larger than 5, that's false. Now let's have a look at this. What happens if you compare a string with an integer? I mean, it's nonsensical that you do this, but Python has an answer for it. So the string 5 is larger than 1, that kind of still makes sense, but the string 1 is larger than 5, that's also true. Why this is happening has to do with how Python works. But what this means is, if you enter obviously the number, then the number 1 is not larger than 2, but the string 1 is larger than 2. And in this case, the database layer, where you request this ID, doesn't care about the type of it, so you are able to request the 1, but the Python code that implements this check is just happy to bypass that comparison. And just for completeness sake, in Python 3 would throw an exception that you can't compare a string with an integer. That's, I guess, how it should be. But anyway, if you didn't get it, it's just a general example of validate your inputs. If you expect a number, make sure that it is a number. And I especially highlight this because of the JSON format. Because in the basic web post request that we are used to with URL encoding, we kind of expect everything to be a string, and we kind of do this automatically. But with JSON, you suddenly have different types. You can have numbers, you can have strings, you can have lists, for example. And so a developer might have the expectation that a certain value that is coming in is from a certain type, and might not do this conversion automatically how maybe they used to be. And so the story is just here, make sure, check everything before you process it. And also, I want to be honest, have I ever seen this in real life in an application? And I have to be honest and say, no. In every Python website or code that I get to audit, I specifically look for these type confusion kind of things, and I've never seen it. But the point is not if this is this a likely vulnerability. The point is, would you have noticed this vulnerability? Would you have tested for it? Would you have tried to enter different types in this JSON format? Would you have tried, or would you have known that these comparisons could be screwed up like this in Python? And that's kind of the story here. And it's great that we have more time so we can get more. So format string vulnerabilities, if you do binary, then it's a basic thing and you know about it. If not, it's maybe hopefully interesting. So when you program C, for example, printf, the first part of printf where you specify how you want the data to be displayed is the format string. And here's another example with 2 variables. So you want this one to be replaced with the decimal representation of the number, and this one to replace with the hex display of this number here. And the format string vulnerability happens when you can control this format string. And so here's kind of how this looks like with a simplified stack in memory. Because printf has a variable amount of parameters, and it basically just trusts that everything is on the stack. So if printf encounters a %d, it will take the first number from the stack and display it. And then it encounters the %x, takes it from the stack and displays it. And you can imagine that when you can now control this part of the string, and you enter as an attacker just a lot of x, that you start consuming a lot of values from the stack, and you will leak a lot of data from it. So this can be used to bypass ASLR, for example, because we know that on the stack is, for example, the return pointer. So you have at least a valid address into valid code, and based on that, you can most likely get around the ASLR issue. But there are even modifiers that allows you to write into memory, and it can be even used to completely take over the control flow of a program. But this is not only the idea, the abstract idea of controlling the format stuff is not only an issue for C. Here's a Python example, and I mean, it's a completely ridiculous example. Who would write this kind of code? But the question is, would you realize that this is happening if you would audit it? And in this case, we don't look so much into it. There's a global config variable, and so you have a string and .format, and this is then the format string part of it. And this is prepare response, it's coming from here. Long story short, user can enter format parameters like curly braces temp or place into that part, and because of format, it gets interpreted. And here's the idea that you do the prepare response because you want to prepend the name of the application. But you also pass in what an attacker could potentially control, and so you can access other config parts. I mean, it's a ridiculous example, but the point is that if you have something like this, in Python, it's also kind of a format string vulnerability. And you are able to then just read and print out the secret key. This, if you look at this in your into web security, you might think this looks very similar to template injection. And in fact, if you think about it, template injection are also just kind of a form of format string. The template specifies how the site is formatted. Okay, so if you didn't get it, format strings can be abused. Make sure that they are usually not controlled by an attacker. Often they are just about leaking data, but sometimes it can be even worse depending on what kind of template engine or whatever you have. How to fix this? Yeah, keep those strings always static. And have you ever seen this kind of double format string from Python? I have also not seen it. Again, the point is, would you be able to see it if you audit this kind of application? Okay, another example has a title, a Chomsky hierarchy. So, Rising Stack is apparently a company that offers Node.js trainings and consultant and development, and they have this Node.js module called Protect that apparently protects against or detects XSS and SQL injections. And they are referencing and based this work on an article from 2004 by Symantec, and you can imagine if that's an old article, it's probably pretty bad. And that site suggested to use some regular expressions. So this is the regular expression that is supposed to detect XSS attacks. There's a cool website called DebugX where you can build the finite state automaton based on this regular expression, so it's very easy to see what kind of strings are matched by this and what strings are not. And so it's pretty clear that, for example, script, alert one, the script parts are matched. It's opening an optional slash, then some characters, and then closing the tag again. And it's also clear how that can be easily bypassed. You just enter a space because this one doesn't match a space, and so it's useless. And the moral of the story here and where the title is coming from is the Chomsky hierarchy. Because in if you have studied computer science, you are aware that the study of formal languages and that certain grammars languages are more powerful than others and require more complicated parsing than others. And so, for example, regular expression are kind of a really good example of what a regular language is because it implements this finite state automaton that you just saw shown by DebugX. And the hierarchy also tells you that if you have a more powerful language, then you can parse or implement the lower, less powerful language, but never the reverse. A regular language can never fully implement, for example, context-free language. And HTML and SQL are so complicated that they are at least context-free. And not to mention that browsers are screwing with HTML anyway. You don't even have to write valid HTML and it still works. So, you know, it's a mathematically impossible task. Yeah. So if you didn't get it, well, don't use regex, especially if you want to try to match very complicated languages. And languages where you have, for example, opening and closing brackets or tags like XML, these are always much more powerful than what a regular expression could implement, because you need an additional stack to remember what is open and what has to be closed again. And in general, how do you fix this? Well, just don't try to detect XSL or SQL at all. Just, you know, try to fix it. That's more like a defense in depth kind of thing. You actually want to focus more on just making sure that this doesn't happen at all. And I can really recommend DebugX. Okay, so you can maybe get one other example. Here's like some kind of language, Sandbox escape. What do I mean by that? So sometimes applications implement some kind of security sandbox. So sometimes you want an application where people can run arbitrary code, but you want it to be safe code. A good example is the browser, where you run code on your machine, but you want it to be secure. And especially Java applets, for example. And Java is a very powerful language with a lot of low-level access to the system, and you want this to run securely. And then you have, but this comes up in many different places. So for example, AngularJS expressions, you can define JavaScript in these expressions, but you want this not to be fully JavaScript, otherwise people can use it to do XSS. So you want to kind of sandbox that so that they can only do what, for the application and not something very intrusive. And then you can also play with that. There are CTF challenges where people implement a Python sandbox where you can submit Python code, but you can't, for example, import OS and then execute system. So here's the example of AngularJS. The expression would be, you would write this, and it would be evaluated like this. And in order to support these complex expression, AngularJS kind of just interprets this as JavaScript. It's not just a full eval, because they, at least in some versions, try to make sure that it can't be abused. But this is the first version where they didn't take care of this. And so the bypass for this is to break out and get access to very interesting functions or objects in the DOM is, for example, you want to get access to like window or document or something like this. And in this way, we can go from constructor to constructor and then call alert. And if you look at this, how this works, you start by a variable, and the constructor of this variable is the number constructor, and the constructor of the number constructor is the function constructor, and you can pass in a string that is code that you want this function to be. So this now creates a new function where the code is alert, and then you can just call it. Here's a Python sandbox example where you can't just easily import OS to call system because that is built and is disallowed and is removed. But you can, from an empty dict, you go over the class, the base, you list the subclasses, you find an interesting subclass, you take its modules, you take its built-ins, and then from that one you can get to the import and OS. And the one that was used here is the warnings, catch warnings object. I mean, it looks crazy, but the moral of the story is that you can, you can kind of escape out of this not allowed object by trying a different path through the objects to get where you want to be. And this is kind of the same thing with Java applets that were used in drive-by downloads on your machine. They were, sometimes they were memory corruption, but sometimes they were just bypassing the security manager kind of thing. And in this case, for example, this proof of concept code is loading a class that you are usually shouldn't be allowed to load. And it's basically doing the same thing by traversing through all the objects available and somehow getting to this find class method that you shouldn't be allowed to get access to. And basically the idea behind all of these sandbox escapes, and this can be generalized, it doesn't matter if it's JavaScript or Python or Java itself, it's basically you have these complicated object-oriented languages that have references to all these objects, and all you do is you try to get to this magic object you are not allowed to access, and you try to find a way through a lot of different objects. You kind of try to traverse the jungle of objects to get to these juicy classes. And that's basic what is happening with any sandbox escape. So you can generalize this and apply this thinking to any other example. Okay, so I didn't get it. Implementing sandboxes is hard. Generally, don't try to run arbitrary code. If you do it, expect a huge overhead that you have to fix stuff like this. I'm already over my time, I'm sorry. If you want to stay in contact, you can find me on Twitter, LiveOverflow. You can also subscribe to my YouTube channel where I have a lot of technical examples. And I'm also happy to hear by email, so if you have feedback of this talk or generally questions and stuff, I try to answer to everybody. Thank you very much for having me, and I guess that's it. Thank you.